Hey there, AP Chemers. Hope you guys had a great weekend. Hope things are going well and you're ready and you took your solubility quiz today and it went good. We're going to do some double replacement reactions today. So we're going to write net ionic equations for those double replacement reactions. If you remember, double replacement reactions are happening between two compounds, and ultimately the key to double replacement reactions is that you're forming a precipitate, formation of gas, or some other substance is forming. And for all the reactions you're given for AP, they always happen no matter what. So a couple things to make note of. If one of your products is NH4OH, it decomposes into H2O and water. I'm sorry. Whoop, what is going on here? Oh my goodness. Seriously? Why does it do this from time to time? So it's going to decompose into water and ammonia. There's a couple other substances that are going to spontaneously decompose as well. So if one of your products is H2CO3, that also is going to break into water and carbon dioxide gas. All right. And additionally, H2, if H2SO3 is one of your products, it also will break into water, liquid water, and SO2 gas. Okay, so that's something to be aware of when it comes to a couple of your products. Because when you form a gas, that's formation, gas formation is a sign of double replacement reactions. Okay, so we're going to run through a few examples here, and we want to get down to the net ionic equation, which ultimately means we're going to get rid of any ions that are not involved in the reaction. Okay, so we're ultimately going to write a pretty simple formula or simple equation for the reaction. All right, so we're going to get rid of spectator ions in the reaction, and all we're going to be left with is the ions participating in the reaction. Okay, so in the way I'm going to do this, this is where the solubility rules come in super handy. Okay, rather than writing this down as AgNO3 for solutions of silver nitrate and lithium bromide, and this will be helpful. You could write the formulas down next to them, but what I want to do is, okay, we know all nitrates are soluble, so that's going to be Ag plus and NO3 minus in solution, and all bromides are soluble except for a couple exceptions to that, right? So it's going to be Li plus and Br minus in solution, and those guys are going to trade partners, right, to form lithium nitrate, and we know all nitrates are soluble. So we're going to write that guy broken up into its ions in solution. And that must mean that, oh, well, silver bromide must be a solid here, and which it is. All right, and that's our precipitate. So what we want to do now is we want to cross out any ions that are ions on both sides of the reaction. It's both a reactant and a product, lithium and nitrate. So our net ionic equation here is going to be Ag plus the bromide ion going to AgBr solid, okay? And that is our net ionic equation there. All right, so we got rid of these guys here. These are spectator ions. All right, lithium, nitrate, lithium, and nitrate, okay? Because they don't participate in the reaction, they just are still ions at the end of the day. Okay, so we'll do a couple more of these here for practice. And so for this one, hydrochloric acid, HCl, right? This is a strong acid, so we know it's going to break up into its ions in solution. It's added to a solution of potassium sulfite. So if you're not sure, right, that whether or not something, a lot of times they're telling you, hey, it's a solution of potassium sulfite. So KSO3 is all soluble, all right, if you weren't sure, right? They're letting you know what it is. So we're going to write these down as H plus because they're all aqueous. All right, Cl minus plus that should be 2, so K plus and SO3 2 minus in solution. So we trade partners and we're going to get one of our partners is going to be KCl, which we know is soluble, so it's going to be K plus and Cl minus. And this one here is going to be H2SO3, right? So, but remember, this is one of our deals here. When you get this as a product, it's going to break up into water, liquid water, and this sulfur gas. Okay, so when we go ahead and we write our net ionic equation, we have H plus SO3 2 minus going to H2O and SO2 gas. So that's a liquid. All right, now key here part is we got one sulfur, we have 3 oxygens, but we got to balance the hydrogen, so we have to put a 2 out front there. So you want to write a balanced equation. Sometimes in the answer key they don't give you a balanced equation, but we want to get into practice of balancing our equations and always balancing them. Okay, so there you go. Let's go on to the next one here. All right. Okay, so we got a solution of sodium hydroxide, NaOH. That's one of our strong bases, so we know that breaks up into its ion solution. So Na plus and OH minus. And into a solution of ammonium chloride, so NH4Cl. So we know chlorides are always soluble, and it's a solution of ammonium chloride. So we switch our flip-flop our products here. One of our products is NaCl, right, which we always know is soluble. So Na plus and Cl minus. And then our other product here is ammonium NH4 hydroxide, right? And this is one of our substances that if you create this guy's going to break up into NH3 and right up here and water, right? We got that. That's another one of our guys that's going to spontaneously decompose into ammonia. All right, that's ammonia gas and water, liquid water. Okay, so we can cross out our spectator ions, chlorine and sodium on each side, and bring down hydroxide. Oops, that's a minus, plus ammonium, H4 plus, going to, and we can just write that as NH3 gas and H2O liquid. That's our net ionic equation there. And that guy already is balanced and good to go. Okay. All right, so we'll do 2 more here. And that'll be that for today. And you guys can practice some more as we move forward here. Okay, so we have dilute solutions of lithium hydroxide and hydrobromic acid are mixed. And they tell us these are solutions already. So we can just put down lithium and hydroxide and hydrobromic acid. So my question is, hydrobromic acid a strong acid? Yes, it is. H plus and Br minus. Right, so what are our products? Well, we make, let's see, lithium lithium bromide, right? So we know that's soluble, LiBr, right? That guy's soluble. And H2O, right? This is a special type of, right? You got a base and an acid, right? Hydroxide. So this is a special type of double replacement. This is a neutralization, right? This is a neutralization reaction. So we can boil this down to just hydroxide and our H ion coming together, all right, and forming H2O liquid. Isn't that nice? There we go, nice and balanced, boom. There's a neutralization reaction. We formed liquid water. All right, and the very last one for today, we got gaseous, right? So this is important. Pay attention to what they're telling you. Gaseous hydrofluoric, which we know is a strong one. So HF, we write that together because it's not strong. This is a weak one, so we don't break it up into its ions. And it's solid silicon dioxide, so plus SiO2. That guy's a solid. All right, so we still do the double replacement reaction. So we end up here with, right, H2O, right, because we got to bring in, so oxygen, and so we get H2O, and silicon, in this case, silicon's +4, right, and fluoride is -1, so it's SiF4 as our other product here. And we're just going to say that that is solid, and water is liquid here. So if I look at this, we got to balance this, don't we? So we need 4 fluorines, and then that would mean 2 more here. Then we got the right number of oxygens, and we got 4 hydrogens, so that's good as well. So there you go. So sometimes the net ionic equation is the original equation. We don't need, there are no spectator ions and stuff like that to do. So we have plenty more here to practice for you. All right, so we want to go through some of those and practice them. And on the next page of this, we have the keys for all of these reactions here. All right, so there they are. All right, so you want to practice these. I do have a double replacement reality coach that you guys can work with each other on. Okay, and work through that stuff with one another. All right, just keep in mind tomorrow. Oh, I'm sorry, the double replacement reality coach will do that tomorrow. But try doing some on your own today and see how it goes. We'll have a quiz over the first few objectives on Wednesday. Okay, so that means that we have some, so we'll work through some of that, and we'll talk a little bit more about that tomorrow. We'll have some time tomorrow. All right, hope you guys have a great day, and we'll be seeing you tomorrow. All right, not today. All right, be easy.